you're confused about how do you choose that smallest number, I'm going to start right now by writing out the numbers that 5, multiples of 5, 5, 10, 15, multiples of 10, 10, 20, 30. What's the smallest number that's in both lists? 10. 10 is the smallest number. That's okay if you get it wrong. 10 is the smallest number in both lists. That means I don't have to touch the 10. The 10's already there. Now, how do I make a 5 into a 10 by multiplying? So I'm going to go times 2 on the bottom and times 2 on top. Now we both have 10 and 10. We're good to go. We both have 10 and 10. The next thing is we're only looking at the bottoms, the denominators. This has an x, this has no x. So I'm going to go times x and times x. Whatever I multiply in the bottom, I must multiply in top. Okay. Next up, what do they both have? They both have just a 10x. I write it down one time. They both have exactly a 10x. There's a left side and there's a right side and there's subtraction in between. The left side has 2 times 3. The right side has 1x. And my question for you is, you're going to answer this within your group. Can I combine a 6? Don't tell me, tell your group. Can I combine a 6 and a 1x? There's a lot of confusion about this. I saw a number of kids that did all of this, but then they said the answer is 5x or the answer is 5. Tell your group right now, can I combine the 6 and the 1x? Go. Not like terms? There's nothing more I can do. This is my final simplified answer. Final simplified answer. Let's go on right now to the next one. Next one. I can, is that? There's nothing more. Like in your problem, that's all you could do. You mean simplify further? For your quizzes, there's not going to be. But as we get into more complicated things later on, there could be. Yes, yes. Okay, here's your next one. Please put down 5x squared plus 4x. On top, let's do a 3x. And over here, let's do a 3. So this is really like example number 1. I would like you in small groups right now to only do one thing. And all I want to know is, don't tell me, remember, tell your group. And for when people don't know, explain how. What's the smallest number? You have a calculator that 5 and 4 both divide into. Not just what do they have. So don't say 1. What do they divide into? Talk to your group. 20 seconds, go. 20 seconds. What are they both going to? Give me 1 second to write this down and I'll answer for you. So I'm writing down the multiples of both right now, and I'm just finding the smallest number that's in both of those lists. So the smallest number in both of those lists is 20. That means I want the 5 and the 4 to turn into a 20. Please take good notes. I want the 5 and the 4 to turn into a 20. And we can only do that by multiplying. 5 times what value is 20? 4 times 4 times 4. 4 times what value is 20? Times 5 times 5. Okay, so I know both of them have a 20 in the denominator. I've taken care of that. I'm going to underline that. That's just like my way of keeping track of things. We're going to get to that next. Now, notice that x squared, that means x times x. There's 2 x's on the left in the denominator, and there's 1 x on the right. They need to be the same. I'm going to come back to your question, Mello, in just a second. So they need to be the same. So if these need to be the same, how many more x's do I need on the right-hand side? 1x. So 1x on the bottom right, 1x on the top. Because whatever I do at the bottom, I must do the top. So over here, I have 2 choices. I can write xx or I could write x squared. Your choice. Either one I'd accept. Now there's a left side, and there's a right side, and there's addition in the middle. On the left side, what is 4 times 3? It is 12 with an x. On the right side, what is 5 times 3? It's 15 with an x. Now turn to your group. Can I combine those? Can I combine a 12x and a 15x? You can only combine them if they're the same. So they have to have the same x's. So I couldn't combine a 12x squared and a 15x. They have to have the same number of x's. Yep. So 12x and 15x. So 12 plus 15, you can grab your calculator, and they each just have the 1x. Now, here's where a lot of you got really close, but then you got it wrong. So take that calculator while I walk over to get one and talk to your group. How do you finish simplifying this? Don't tell me. Tell your group. Go. How do you finish simplifying? Talk as a group. So not everybody has strong multiplication skills, and that's what helps with simplifying. So we can use one of the apps on the calculator that actually simplifies for us. So I'm going to type in 27 divided by 20, and then I'm going to hit math, fraction, enter, enter. And now we can see that it didn't simplify any further, so I know 27 over 20 in terms of just the values is as simplified as it goes. But let's look at the x's. I can do a 1 for 1 because I'm multiplying on both the top and bottom. So 1 for 1. Remember, they don't just disappear, they don't just cancel out, really they're going to simplify to a 1. After I simplify, there's only one x left, and it's in the bottom location. Can I have right now an honest thumbs up or thumbs down if you're feeling okay with this? Okay, let's look right now at the next one. Definitely going to get a little more challenging with this third example. We're going to go 3x over x squared, subtract 7 over 2x. I don't want you to do anything more on paper. I just want you as a group. If I said, hey, I'm going to give you a quiz right now, and it's only going to be a verbal or oral quiz, what would you do first? So I can think of two different things I would do. Nothing on paper, only talk. Nothing on paper, only talk. I can stop you 20 to 30 seconds. Go. What would you do? This one was wrong the majority of the time for students. Go. What would you do? Okay, are you ready? Here's what I'm going to do. I'm going to rewrite x squared as x and x. And then, by the way, what number is in front of the xx? A 1. So the first thing I'm doing is I'm going to choose to say, okay, what number do they need to become? So we can only do this by multiplying. So what number does 1 and 2? Well, let's think, what are multiples of 1? 1, 2, 3, 4, so on. Multiples of a 2, 2, 4, 6. What's the smallest number in both of these lists? A 2. So I want them to become a 2, and I can only do that by multiplying. So I'm going to multiply the left side by 2 on both the top and the bottom, and then personally I'm going to underline those 2's. The next thing is the x's. How many x's do I want? 2. I want 2 x's. See how this has 1 and this has 2? We're always going to rise up to the largest number. So the largest number of x's is 2. So I already got 2 x's on the left-hand side of the denominator, but on the right-hand side I only have 1. I need 1 more. So x and x. Whatever you do to the bottom, you must be fair and do to the top. Now, they both have a 2xx, or you could write it as 2x squared. I have a left side and a right side, and separated by subtraction. On the left side, 2 times 3 is a 6. On the right side, I have a 7x. Can I combine 6x and 7x? Yes. So on your calculator or in your mind, what is 6x minus 7x? Be careful. Negative 1x. Okay, you ready? This is what somebody hands in. They circle this, and I say, oh, you're so close, but you're wrong. Why? Don't tell me, tell your partner. Why? Everything I've done is right up to this point, so why can this not be your final simplified answer? Go. You have 15 seconds. 15 seconds. So the x on top and the x on the bottom simplify, and I'm left with negative 1 over 2x. Negative 1 over 2x. That is my final simplified answer. Yes, ask me. When is it going to be negative? Is that your question? Okay. So you're wondering, how do I picture this? So let me give you another example of something like this. If I said 15x minus 13x, right? So on your calculator, forget about the x's. As long as they have the same number of x's, you're just going to type in 15 minus 13. 15 minus 13 would be a 2, and there's an x. But let's switch it up. Let's say if I said 14x minus 20x. Well, they have the same number of x's, so I can combine them. So now you type in 14 minus 20. 14 subtract 20 is a negative 6, and there's your x. Does that help you? Okay, let's go on. We're halfway done today before you make your corrections or grade changes. Here we go. Here's our next one. It's going to get more complicated. Really, we're going to talk about it later. You must take notes today to have any chance on retesting. Okay, here's your next one. We're going to go with a 2 x plus 1 on top is a 3 plus 7 over 6x. After you write this down, please listen. I know you're listening. You're doing the following. Please put your pencil or pen down. Once you put it down. There's multiple ways you can do this. What would you do first? You have 10 seconds. Don't do it on paper. Only talk. What would you do first? Talk as we go. What would you do first? I'm hearing some groups say I would add. Can't do that. I would not distribute. Cannot add. Here's what I want you to do. Underline the 6 and the 2, please. Underline the 6 and the 2. Underline the 6 and the 2. Ready? Underline the 6, 2. Now, I'm going to do this 2, 4, 6, 8. I'm doing multiples of 2 and then multiples of 6. So 6 plus 6 plus 6, right? What's the smallest number that occurs in both lists? So I want them both to turn into a 6, but I can only do that by multiplying. Well, I already have a 6 here. This is great. But to turn 2 into 6, I have to multiply by 3 times 3 times 3. Now they both have 6. I'm good with that. I know they both have a 6. Let's do the next thing. This has a single x, not an x plus 1. That's different. It has a single x. So the bottom right-hand side has a single x, but the bottom left-hand side does not. So I need to attach an x to both the top and the bottom of the left-hand side of this expression. Now they both have a single x. What else are we missing? X plus 1. So we have an x plus 1 over here on the left, but this is missing an x plus 1. This is missing an x plus 1. Now they all have a 6, they all have an x, and they all have an x plus 1. On the left-hand side, I have 3 times 3. Okay, that's 9, and there's an x. On the right-hand side, I have 7 times x plus 1. Now it's time to distribute, but only in the numerator. We are not distributing in the denominator. So I'm taking this positive 7, and I'm going to multiply it right now times the x and the 1. So 7 times x is 7x. 7 times 1 is a positive 7. How did I get the x? Remember they both had a singleton x on the bottom? And they had an x plus 1. So this is what they have in common in the denominator. They both have a 6, a value of 6. They both have a single x, and they both have an x plus 1. Okay? Yep, ask again. How did I get another 7? Because 7 times x is 7x, and 7 times 1 is 7. Yep, just distribute it. Now on top, give me 1 second, Andy. Andy, there's 3 terms on top. Which 2 can you combine? Why can you combine 9x and 7x but not the additional 7 over here? Doesn't have an x, right? So 9x and 7x is going to be 16x, and then we have this lonely 7 I cannot combine it with. Andy, what can I answer for your question?
Does that singular x, does it always have to be in parentheses?
Doesn't have to, but it makes it pretty. Yep, doesn't have to. That's my final answer. By the way, you cannot do this. Look up here. You cannot cancel these x's, because it has to be in multiplied form. So if these were being multiplied, great, but this is not, so we can't just cancel those single x's. Yes? Sure, so up here, this 7 has to be multiplied by everything behind it. So we're going to go 7 times x is 7x. 7 times 1 is positive 7. Okay, here is your next one. We are getting close to being done. Here's your next one. I'd like to thank you for your concentration. I truly appreciate it. Here we go. X squared minus 25 on the bottom plus 2x over x minus 5. In the denominator of the first fraction, my question for your group is, how do I rewrite the denominator of the first fraction? That means the bottom of the first fraction. How do I rewrite that into something equivalent? Go. So how do I know this breaks into x plus 5 and x minus 5? Well, x squared breaks into x times x. 25 breaks into x, or 5 times 5. And so we have x plus 5 and x minus 5. All right, so let's look at the left and the right. They both contain an x minus 5. Let's underline that. But the right-hand side is missing something. Whoever you believe is the tallest in your table, what is the denominator of the right-hand side missing? Go. What is this side missing? It's missing another parenthesis. What is it missing? X plus 5. And whatever you do to the bottom, you must do to the top. Now, both sides have an x minus 5 and an x plus 5 in the denominator. And so there is the top of the left, and then we have the top of the right. And we can't stop here. We do have to distribute before we're done. So this is going to work just like we did up here. It's just going to look a little bit uglier. It's a little more complicated. So here we go. Is everybody ready? I'm going to focus in here so everybody can see this. I'm going to distribute right now. In front of this x is a 1. So here we go. You ready? I have, just the numerator. 2 times 1 is 2. But how many x's do I have between these two? 2. 2 times positive 5 is 10. How many x's in the second one? 1x. None of these can be combined because this is a single number, no x's. There's nothing else single number. This has an x squared. None of these have an x squared. This has an x. Nothing else can occur. I have x minus 5 and x plus 5, and I fully simplified this problem. Turn to your group. Honestly, you're doing a phenomenal job working together. Talk amongst the group, and I will re-answer any questions. The confusing part for people is that distributing. Go. Talk to your group. I'm looking at your paper to see who's taking notes right now. How do you feel about this one? Okay. Mello, does your group have any questions about this? Alex, you have any questions, Tian, about this one? We're going to talk about this later. Just focus. Where did I get the 1x plus 5? This side only had an x minus 5, but it has to look exactly the same. So I had to attach an x plus 5 so that the left and the right were exactly the same. And whatever we attach to the bottom, we also attach to the top. And then I multiplied on top. Yep, I distributed this. Yep. Okay, we are down to our last one. Are you ready? We have done so much work with factoring. Let's see what we can do right now. Here we go. Please write 3 over x squared minus 1x minus 12 plus 2 over x minus 4. Okay, you ready? Hands raised right now. What do I do with this? That would be a great guess. That's a great guess, Joe. But x squared, negative 1x, negative 12 are all different, so we can't combine. That's a great guess. There is a word that's not a square word that starts with an F that we could do here. We have to factor. So everybody write factor underneath. So how do we factor? We're going to take the front, which is a hidden 1, and a negative 12. So 1 times negative 12 is negative 12. And I'm asking myself, what two numbers can multiply to equal negative 12? So they're going to be different signs, and they combine to give us a negative 1. Does anybody have any ideas? 4 and 3, nice job. This tells me the larger of the two numbers is negative. This tells me the larger of the two numbers is negative. This tells me their signs are going to be different. Okay, I like that. Okay, so I'm going to rewrite this as 3 over x minus 4 and x plus 3. I like it. That's ugly, ugly too. So I have factored, and this is what I have right now. I have factored, and this is what I have. Okay, next up, do not say it. So it's so easy for you just to blurt this out. I want you to raise your hand. What is the, that's an ugly two on top, sorry. What is talk in your groups. What's it missing? Go. They need to look the same. It's missing this x plus 3. Otherwise, they look exactly the same. So let's put down an x plus 3 on the bottom and an x plus 3 on top. X plus 3 on the bottom and an x plus 3 on top. Okay, is everybody ready? Now, the bottoms look exactly the same. X minus 3 and x plus 3. We have a left side and we have a right side. We have a left side and we have a right side. Okay, next, within your groups, what is the next step in the numerator? That means the top. Talk in your group. I heard one person say it, that fact group. What do we do next? Distribute. So please, you're going to make these like upside down U's, like rainbow looking shapes. And when we distribute, we multiply. So I'm only focused in the numerator. There's a 3, and positive 2 times x is positive 2x, and positive 2 times 3 is 6. So I'm only looking at the numerator. I've got 3 items here. Which 2 can I combine? 3 and 6. So 3 plus 6 is 9. It doesn't matter if you say 9 plus 2x or 2x plus 9. Either one is going to be correct. Please circle this.